So in this video, I have a wonderful physics problem where we have a 55 kilogram person wearing a mixed matched set of heels. One's pointy, one's wide. We're asked, okay, what's the pressure for each, given that the wide heel is 16 square centimeters in area, while the pointy heel is 0.45 centimeters squared in its area. Okay, so this problem can be kind of tricky, but it's good just to draw a free body diagram. Okay, so we have 55 kilograms, and we're going to represent the girl as a box. I'm sorry, that is very inhumane. There's two stilts on the lady supporting her, right? We have the pointy heel and the wide heel. The pointy heel and the wide heel are both exerting a force onto the earth, mass times gravity. But notice something. It's only 1/2. That mass times gravity force is being applied to both. So they both get it equally by 1/2. So this is 1/2 mass times gravity for each, right? So the one stilt's taking half of their mass times gravity force, the other one's taking the other one, and it's helping support the lady. Okay, so we can use this idea to solve for each respectively. Let's start with our pointy heel. We know that pressure is equal to force over area. We could rewrite this as pressure is equal to mass gravity 1/2, right? Because we said that bearing the weight on one of the heels is only 1/2 mass gravity, and over area, and we already know the area, so we don't have to expand that anymore. Okay, so let's solve for pressure. And before we do that, let's convert our area to square meters, right? Because Newton units are in meters, not centimeters. 0.45 centimeters squared. For every 100 cubic centimeters, we have 1 square meter. Okay, and when we do that, we have to square 100 here to actually do a correct conversion. So it's 0.45 divided by 100 squared, which gives us 4.5 times 10 to the negative 5 meters squared. It's a very small area. Okay, so let's plug in now. Pressure equals, and we'll put 4.5 times 10 to the negative 5th meters squared over mass, which is 55, times gravity, 9.81, times 1/2. And we find that this is 270 newtons. Okay, so we take 270 newtons. Notice how it's newtons over square meters. That's going to give us exactly pressure. So you take 270 divided by 4.5 times 10 to the negative 5. We get that the pressure bearing down is 6.0 times 10 to the 6 newtons per square meter. Okay, so that is a lot of pressure, but notice that it's only over an area of 0.45 centimeters, so it's not that amazing. We could also convert it to kilopascals, because this is also a pascal. We can convert it by dividing by 1,000. I won't go ahead and do that, but you could put your answer in kilopascals if you so wish. Now let's find the pressure of the second heel. It's the exact same formula, so I'll just do some erasing and we'll actually save this formula to help us find the area. So notice that our one heel is taking a very, very, very large amount of pressure, but we'll see that the wide heel won't take as much. So 16 centimeters divided, so 100 centimeters on the bottom. We do our simple conversion here. So 16 divided by 100 squared, that gives us 1.6 times 10 to the negative 3rd square meters. Now we can do some more plugging and chugging, so to speak. And we'll find that when we do the math, 55 times 9.81 times 1/2 divided by 1.6 times 10 to the negative 3rd. We find that our pressure is equal to 1.69 times 10 to the 1, 2, 3, 4, 5 to the 5th power. So just a little less, and this is in newtons per square meter, or simply pascals. So notice we have a lot less pressure, right, that we give in a heel. And this is, any girl who wears heels knows that if you wear a pointy heel, your feet get really sore after a while, but if you wear a wider heel, it doesn't get as sore. That's because of pressure. I hope you guys enjoyed. If you did, please like and subscribe. Comment if you have any questions on how we got these answers here, and I would love to answer them for you. Have a wonderful day.